Okay, what we are going to try to do now is to solve the equation sine theta minus cosine theta equals the square root of negative square root of 2. And there are two different ways to do this. The first way is to complete the square. And the second way is to use an identity. Okay. So let's try the completing the square technique first, and then we'll use this, the sum or difference identity to try to solve this. Either way is acceptable, but one thing that we have to remember with completing the square is that whenever you're completing the square, you always have to check for extraneous solutions. And I don't want you to forget about doing that. When we use the identity, we won't necessarily have to do that, but completing the square we always do. So if we started out with completing the square, we would square both sides of the equation. So we would get sine squared theta minus 2 sine theta cosine theta plus cosine squared theta is equal to 2, positive 2. We know that sine squared theta plus cosine squared theta is 1. So we have 2 sine theta cosine theta plus 1 equals 2. And if I subtract that over, I get 2 sine theta cosine theta equals 2 minus 1, which is 1. Divide both sides by negative 2. And I get sine theta cosine theta equals negative 1/2. Okay? And that's what now we have a product of a sine and a cosine that equals negative 1/2. But if we think about this, we can figure out what theta ought to be. So before we go on, so if we have sine theta cosine theta equals negative 1/2, we're going to look at the graph of it. If here I graphed y equals sine of x minus cosine of x, and y equals negative the square root of 2, there's one point of intersection in the interval from 0 to 2 pi. Okay. If we actually calculated that, this is 7 pi over 4 is 5.498. So we can have an idea of what our solution is, and in fact there's only one solution before we go on. What we want to do is we want to think of the angles that we know, and could we multiply any of these angles, any of these values, the sine of a particular angle and the cosine of that same angle, that would give us negative 1/2. Well, we know that at 45 degrees, or pi over 4, the sine of theta is the square root of 2 over 2, and the cosine of theta is the square root of 2 over 2. And if we multiply those together, we get 1/2. But what we really wanted was negative 1/2. So maybe if we multiplied, if we thought of whatever quadrant, say that the angle was in quadrant 2, then the sine would be negative, right? Or if we did this and we thought of the angle being in quadrant 4, then the cosine would be negative and the sine would be positive. Or hang on a second, the other way around. This was quadrant 4. If we think of this as quadrant 2, then the cosine is negative, but the sine is positive. So let's draw a picture to see that. So if I'm over here in quadrant 2. The sine is positive in quadrant 2. The cosine is negative in quadrant 2. So this angle would be 3 pi over 4. Over here, if the sine is going to be negative but the cosine is positive, we know that we have to be in quadrant 4. So that would be the angle 7 pi over 4. So now those are our possibilities, that theta is equal to 7 pi over 4, or theta is equal to 3 pi over 4. But remember, we're talking about solving this by squaring both sides. So we have to go back to our original equation, sine of theta minus cosine of theta, and it should equal negative the square root of 2. So I know that if this is the sine of 7 pi over 4 minus the cosine of 7 pi over 4, that equals negative the square root of 2 over 2 minus the square root of 2 over 2, which equals negative 2 square roots of 2 over 2, which is just negative the square root of 2. So that is a solution. So theta equals 7 pi over 4 is a solution to our original equation. Now if we check 3 pi over 4, we know that it has to solve or be a solution to the original equation. So this is going to be the sine of 3 pi over 4 minus the cosine of 3 pi over 4, and we want that to equal the negative square root of 2. So the sine of 3 pi over 4, it's in the second quadrant, that's positive, the square root of 2 over 2, minus a negative square root of 2 over 2, because the cosine is negative. But when we subtract those, we're really adding a positive, which turns out to be 2 square roots of 2 over 2, which is positive square root of 2 over 2. So it doesn't equal negative square root of 2 over 2. So this is not one of our solutions. The only solution we got was theta is equal to 7 pi over 4. That's one method of solving this equation. But we can also solve this equation, sine theta minus cosine theta equals negative square root of 2 by using an identity. And so what we're really going to do first is we're going to multiply both sides of this equation by 1 over the square root of 2. And the reason that we do that is because that 1 over the square root of 2 is equal to the sine of pi over 4 and the cosine of pi over 4. So what this really looks like, or what we can think of it as looking like, is the sine of theta times the cosine of pi over 4 minus the cosine of theta times the sine of pi over 4, and that is equal to negative 1. Now we can look at this and say, hey, that is the difference of sign formula, right? So this is the sine of theta minus pi over 4 is equal to negative 1. So what I'm really thinking of is, what should this angle be if I take the sine of it and I get negative 1? It has to be in the quadrant from 0 to 2 pi, because that's what we're looking for, the angles that would be in there. So I know that if theta minus pi over 4 is equal to 3 pi over 2, that would give me the sine of 3 pi over 2, which would equal -1. And that's the only value in that interval from 0 to 2 pi. So if I solve this for theta, by adding pi over 4 to each side, I get 3 pi over 2 plus pi over 4, which is really just 6 pi over 4 plus pi over 4, which is 7 pi over 4. So we were able to get our solution just by using a trick. And sometimes in math, tricks help you to solve something more efficiently. But if you don't recognize that you can do that, then you can always square both sides and solve it that way.